And so we can do this in looking at soil. And so what we did was we were also compared different metropolitan areas. Again, we used distance on the bottom. So urban to the left, rural to the right. And the top, the triangles, solid triangles are New York City, Baltimore are the open diamonds, and then the circles, closed circles, Budapest, Hungary. And you can see that as you move away from the city, you get less lead. As you move away from the city, you get less copper. And they're, you know, because the cities differ in size and so on and so forth. So we have this potential for heavy metal contamination, and this was all correlated with traffic volume. I don't want to, I have a slide of this, but I just don't have time to show you. But traffic volume correlated with this. So what was happening around those forests as far as emissions was definitely having an impact on what was accumulating in the soil. And so when you have a microforest and you're managing a microforest, it would be good to know where along this gradient your microforest is. Your downtown area, potential for lots of pollution, versus on the outer edges, a little bit less. And you have to think about sources. We looked at soil biota, and we got these Asian jumping worms. Amenthus is the genus that were showing up in our forests. A lot more of them in the urban versus the rural. What are the sources? Well, horticultural products, people moving compost around in their backyards, introducing these worms into these systems. These worms can have a huge impact on nitrogen dynamics, for example. They wipe out the litter layer, but they also really ratchet up the nitrogen transformation processes, which means it can become more leaky of nitrogen. So more nitrogen can end up in groundwater and then surface waters. So when you're managing then a microforest, you need to think about those indirect effects. And that's the bottom line there. We'll come back to that in a little bit. So let's look at some direct effects in the urban soil mosaic. And these are plots that we set up in Baltimore City. We stratified by land use, and we avoided atypical soil conditions. And there were 126 plots, and we took a lot of data in these things. And this is that black line divides the coastal plain from the Piedmont. I'm not going to show you that data, but basically we did get differences between those two provinces. So this is all the data put together, and I'm showing this to you for two reasons. One is there's a huge variance in that landscape for bulk density and pH, and you're going to see for the other things we measured as well. So there always was this idea of a typical urban soil. Well, forget about it. It's not the case. This is why you have to go out and measure what's in your soil. Bulk density ranged from from 0.71, which is like compost, to a maximum of 1.74, which is almost asphalt. So huge range out there. pH, the same thing, maximum 7.6, minimum 3.3. So these are huge differences out in that landscape. And if we look at means and medians, it gives you an idea. And then if we look at, these are cations, and these are the macronutrients. Plants need this stuff. And what you see here in the yellow are the USDA guidelines for, if you're going to try to grow crops, you're going to want to be between 70 and 150 potassium milligrams per kilogram of potassium in your soil. Well, look at the white number above those yellow numbers. They're pretty darn high. So the other point of mine to make here is that urban soils aren't necessarily infertile. Sometimes they're actually overfertile. But again, it's really hard to say that there's, to designate what a typical urban soil is. Getting back to, so I didn't show anything about heavy metals. And so I just want to give you an example of how we are working at looking at this new heterogeneity. And so this is work done by Kirsten Schwarz, who was a student when I was working in Baltimore, and she was able to take thousands of measurements of lead concentration at the surface of the soil because she had a sensor, a gun that can actually measure it in the field. As long as that gun is calibrated, she can give you pretty good numbers at the surface of those soils. And so she was able to develop a mathematical statistical model of what are the primary factors, variables that are explaining what she was finding in the landscape. These red dots indicate areas that the model predicted would be higher than 400 parts per million of lead, which is not good. That's high. And so she was able to do that with housing age, distance to a building, and distance to a road. 3 variables explain 40% of the variance. So this is the kind of thing that we're doing now to get an idea of this new heterogeneity that we're finding in the landscape. I'm going to come back to this for microforests in a little bit. So kind of sum all this up, direct versus indirect effects. This is a graph of methane flux. On the left, you see methane flux. And notice the line across the top is 0. And that most of the bars are below that line, meaning the soil is a sink for methane. And that's good because methane is a very strong greenhouse gas. And so soils are a big sink for any methane that's being produced in the atmosphere. It goes into the soil. Notice that the rural forest has twice the sink of an urban forest. I'm not going to get into the reasons why, but I just want you to see that. And then when we compared that to a lawn nearby the urban forest, there's no sink at all. And in fact, it was a source in one case. So we have an example of an indirect effect, and we have an example of a direct effect. And the direct effect is way bigger than the indirect effect. And so when you think about your microforest, you need to think about these indirect effects, even though they're not going to be as strong as a direct effect. But these forests largely are being impacted by indirect. And so we have to have an understanding of what's in the matrix as an example. And we have in the matrix, we have non-native plant introductions, there's pollution sources, invasive animals, and those sorts of things. And as I showed you, all can have a potential impact on those soils. But the other thing you need to be aware of are what we call edge effects. And that's because at the edge of the forest, if you have a lawn or a road, then an edge of a forest, most of the deposition that's coming out of the atmosphere is going to occur at the edge. And why that's important, so we have total patch size, area of edge or interior. As the patch size gets larger, we have way more interior than we do edge. And the interior is going to be lower in, say, heavy metal accumulations than on the edge. That's the point there. Okay. And roads, as it turns out, are really a big and widespread source of all kinds of pollutants. We get zinc coming from tires, copper coming from brake pads, lead historically coming from gasoline, not anymore, but that historic deposition of lead from gasoline is still there in the soil. There's sodium, there's chloride in the colder areas of the world where they ice. And then there's NOx and methane emissions, not methane, ammonia emissions coming from car exhaust. And so work done by Remy et al. In the Boston area shows that as you come in from the edge, as you go out, so you're in the at the edge and going away from the edge, these concentrations of nitrogen, for example, in the soil go down. So there's that edge effect you need to think about. So some management and restoration rules of thumb. And this would be, you have to understand the context, first of all, of your forest. You have to know what that context is. Is it suburban? Is it urban? What are your sources? And things like that. So what you can do, you really need to focus on what you can and cannot control, especially with indirect effects. because environmental changes, the urban heat island effect, you're going to have very little control over that. You have to live with it. You have to learn to live with it. Lots of invasive species you're going to have to learn to live with. Once they get established in the system, it's almost impossible to get rid of them. But you can control them in some cases. So you need to set realistic goals based on what you do have control over and what you don't have control over. If you have a soil that's high in clay content, for example, means it's very compactable, or silt, they're very compactable, you're going to want to keep people from walking over that soil, because once it gets compacted, you're done. So set realistic goals and understand your system, what you have control over and don't have control over. So minimizing human disturbances is a big one. And I'm really going to emphasize you need to maintain your forest floor. I didn't get a chance to talk that much about it, but on that photo on the right there, that's a nice forest floor, and that forest floor can infiltrate lots of water, but it also is like a mulch for your tree roots. It's habitat for lots of soil organisms, and so on and so forth. It's really important that you maintain that as much as you can. You really want to control your edges if you can. You want to be able to control use, because again, if you have a compactable soil, you don't want people eroding away the litter layer. You don't want that soil compacted. And we found in New York City, I used to work for New York City Parks, signage really provides an identity for these systems. And when people understand what you're trying to do, they'll give it way more respect. You want to defend against invasive species. And for soils, those earthworm species, you have to be really careful, because once they get in there, it's really hard to get rid of them. But there are also invasive plants that have a huge impact on the soil. I wasn't able to go into that, but you really want to be able to deal with these things. And just remember that removing vegetation in itself is a disturbance. So you have to, you want to deal as early as possible with them. And again, you want to minimize those soil disturbances. You want to consider the natural disturbance regime. You don't get a lot of fire down where you are, but in our neck of the woods, we had lots of potential for fire. And when trees fall, you try to leave them. You try to keep things as natural as possible. I know in some microforests, people want to utilize them for various things, but again, you want to minimize disturbance and minimize changing things. And consider planting in gaps. So if you have a gap in your forest, microforest that forms because a tree falls over, you want to fill it as fast as possible. It'll prevent erosion, but it'll also prevent invasive plant species from coming in. You want to expand patch size, and you want to be able to control the edges. That upper right-hand photo there I got offline. And you need to know your resource. You need to go out there. And remember, there's no across the board single type of urban soil. There's no typical urban soil. So you need to go out there and you need to take samples. You need to look, you need to take measurements and work with your local ag department, soil scientists, whatever, to do that. And that shot in the middle there is the urban soil mosaic shown as soil series that were delineated by a soil scientist in the city of Baltimore. And the soil scientists are doing a way better job of doing that with urban soils these days. So to finish, I want everybody to think about what's missing from this photograph. I got this off of a MicroTree website, and they had the canopy layer, they had the subcanopy layer, and they had the shrub layer. What's missing? Okay, I have to tell you, the forest floor layer, right? It's very important that you think about that. And if you have any questions, you can get in touch with me, I believe, through email. I'm more than happy to address any questions. Thank you.